Hello viewers, in this film we are going to discuss the various electronic components which are used in the field of power electronics. Now before we go to the components, I would like to introduce to you what is power electronics. As the name indicates, power electronics is a combination of electrical power engineering and electronics engineering. This subject is mainly used for controlling electrical power, equipment, apparatus and systems. This was earlier known as industrial electronics, and the limitation there was the components were of very low rating, but gradually with more research taking place, high power rating devices and components were invented, and now the subject has been renamed as power electronics. One of the foremost semiconductor devices which is very intensively used in the field of power electronics is the thyristor. Thyristor has made a revolution in the field of power electronics. With the invention of thyristors, we have other devices such as converters, inverters, choppers, dual converters and so on. All these devices are very much used in the industries for the control of power systems, equipment and machines. Here we have brought some of the components. You can see these are some of the components which are brought here for the purpose of demonstration, and these are very much used in the field of power electronics. Now to talk about the components, the basic components are the resistors, the capacitors, diodes, transistors, UJTs, uni-junction transistors, SCRs, silicon control rectifiers, diex, triax and general purpose ICs. Out of these, this makes a group called the thyristor. Now in this film we are going to discuss about two basic components, the resistors and the capacitors. To start with, I will deal with resistors. Now resistor, as you all know, is a current limiting device. Depending on its value in any circuit, the current can be limited. Now construction point of view, a resistor can be mainly classified in two types. One is known as the wire wound type and the other one is known as carbon film type. The carbon film type of resistor is the one in which you will not find anything printed on it. These are the carbon film type of resistors where you do not find anything printed on it, any number is printed on it. But these are the wire wound type of resistors. Here you find that some value is printed which indicates what is the value of this resistor. Now before we take up detail, we have to know what are the specifications of a resistor. There are two main specifications in a resistor. One is its resistance value, resistance. The value is given in ohms. The other one is its wattage. The value is given in watts. Now there are methods by which we can find out what is the value of a resistor, similarly what is its wattage. The wattage means as you go higher and higher voltage, it will have more bearing capacity of current. Here you can see this is a very thin resistor, then thicker, thicker, and so on. This is a quarter watt resistor, half watt, 1 watt, 2 watt, 5 watts, and so on. So this thickness of a resistor shows what is its wattage. Now to know its resistance values, there are two methods. One is known as the color coding, and the other one is known as, of course, by using multimeter. Color coding. Let us see how do you find out the color codes for a resistor. Here you will find there are bands printed on these resistors. Okay? If you take this, for example, this resistor, there are 3 bands of all orange and one is a golden band. Similarly here you have different color bands. Now what does it mean? You probably remember that old proverb of B.B. Roy of Great Britain had a very good wife. Now some values have been attached to all these letters: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Means B stands for 0, B1, R2, and so on. What does it mean? B is black, B is brown, then red, orange, yellow, green, blue, violet, grey, and white. Now if you find out, if you see here, you will find in this case there are 3 bands which are all orange. And what is this orange stands for? Orange stands for 3. That means the first band is 3, the second band is also 3, the third band is also 3. Now what will I do? I will write 3 for the first band, 3 for the second band, and the third band gives you a multiplier of the power of 10. So it is a multiplier of the power 3 of 10. So this is the value in ohms of this particular resistor. What does it mean? This is equal to 33 kilo ohm. This is the value of this particular resistor. Now let us take the second case, this one. Here you find that the bands are blue, violet, black, and gold. The value will be blue. Blue stands for 6, so I will write 6, then violet 7, I will write 7, and black. Black stands for 0, so 10 to the power 0. So much ohms, this is equal to 67 ohm. That means the value of this particular resistor is 67 ohm. Now you will ask me probably, what is this fourth band? The fourth band gives the tolerance of a resistor, and there could be usually 2 types of band. One is gold, the other is silver. In case of gold, you find that here it is gold, here also it is gold. Gold is plus minus 5% tolerance, and silver is plus minus 10% tolerance. So I know what is the value of the resistor and what is its tolerance. Now from the operation point of view, the resistor can further be classified in 2 more classes. Let us see what are those. It can be either a fixed resistor, symbolically shown like this, or this, but it can also be variable resistor, symbolically shown like this or like this. The fixed, in case of fixed resistor, you will find that there are 2 terminals, F1 and F2, similarly F1, F2, but in moving type, variable type, you will find that there are 3 terminals. I call it F1, F2, and I call it moving terminal M. So there is a third terminal here. Here you can find out all these are variable type resistor. These are also variable type, which I will talk later, but here you will find that there are 3 terminals coming out. There are 3 terminals coming out, and the terminals are fixed 1, fixed 2 and moving. Now if I move this with the help of this stud, if I move it with this stud, what will happen? This movable terminal, the stud is connected to a wiper, which on moving the wiper will move on these granules and the resistance value will change, but the resistance between these 2 fixed terminals will not change. The resistance between fixed terminal 1 and M will change, similarly F2 and M will change. Similarly here, if this is the movable terminal, these are fixed terminals, resistance between F1 and M will change, similarly F2 and M will change, but resistance between F1 and F2 will remain constant. Now this is another category of resistor. One, it is known as variable resistance, but this particular resistance is dependent on potential, so it is called VDR, voltage dependent resistor, and this is LDR. This particular resistor is LDR, light dependent resistor. VDR, voltage dependent resistor, and LDR, light dependent resistor. Now as the name indicates, in this case if I change the voltage across this, its resistance will change. Similarly if I change the light on this type of resistor, the resistance will change. Now the same thing, the values of the resistor can be checked with the help of a multimeter, which we will like to see, and I request my colleague Mr. Singh to demonstrate them with the help of multimeter. You see, we have checked earlier, we have calculated the value of this particular resistance and it was 33K, and here this multimeter also showing 32.8, that is say 33K. The second one we calculated, it was 67 ohms. He has to change the range and it is showing 67, 66.9. You can say it is a 67 ohm resistor. Now if we see in case of LDR, now LDR means I said that its resistance will vary with the help of light falling in. I change the value of light, you see resistance is changing. Change the light, yes it is changing. Value of light is now its value is different. So depending on the light falling on the surface of this type of resistance, its value is changing. Now this type of resistor we call it potentiometer. It has 3 terminals. This is a variable type of resistor. As I move its stud, the wiper will change its position and the value is changing. You see its value is changing, and the value will be changing from its minimum value to its maximum value. So the second component is capacitor. You see capacitor is a very important component, and it is mainly used for storing electrical energy. Symbolically we can show it like this. These are the 2 electrodes and these are the 2 terminals coming out. The 2 electrodes are separated out with the help of a dielectric medium. Depending on the medium, there are various types of capacitors. You see the ceramic disc type, the polyester type, this polyester type, dielectric capacitors and so on. Now if I give a supply to a capacitor across the terminals of a capacitor, what happens? If it is a DC supply, then it will give a very high resistance to the circuit and will try to block the DC. That is why sometimes we call it DC blocking capacitor. But in case of AC, it gives a very low impedance and very easily the current passes through it. So when I connect a supply across the two terminals, across its electrodes, it gets charged and it stores energy, and depending on the utility, by discharging the capacitor we can utilize the energy stored in it. Now again, the value of a capacitor. What are the two specifications, important specifications of a capacitor? The two important specifications of a capacitor are its capacitance and its voltage. The capacitance is usually in microfarad or sometimes picofarad, and the voltage of course in volts. Microfarad means 10 to the power minus 6 farad, picofarad means 10 to the power minus 12 farad. So in case of some of the capacitors, the value is printed or some value is written on it. There is a trick how to know the values. Now if you see this one, which is a disc type of ceramic capacitor, I can see that there is a figure written on it 224. Let us see what is this 224. 224. I will write 2, then second figure is also 2, and this 4, that is the third figure, is the multiplier of raised to the power of 10. So it is 10 to the power 4, so much it will come always in picofarad. This is equal to 22 into 10 to the power 4 into 10 to the power of minus 12 farad, and if I solve it, this will become 0.22 microfarad. So the value of this particular capacitor is 0.22 microfarad. Now let us see this polyester capacitor. If you see it minutely, it is printed 0.047 microfarad. Now 0.047 microfarad it is printed, so there is no problem at all. You can safely take that this is a 0.047 microfarad capacitor. Now let us come to this particular capacitor. This is also a polyester type of capacitor, but here you find that there are certain bands, color bands, like you had in resistors. The first band is brown, then black, then yellow, then again brown, and then orange. Now the brown, as you know, brown stands for 2. I write 2. I write for the first band, I write brown. Brown means 1. Brown stands for 1. The second band is black, that means it is 0. And the third band is of course the multiplier, and you find that this is yellow here. So it is 10 to the power of 4. So much is the value of course in picofarad. Now if I change it, this will be equal to 10 into 10 to the power 4 into 10 to the power minus 12 farad, and on solving I get 0.1 microfarad. So the value of this particular capacitor is 0.1 microfarad. Then there are dielectric capacitors, electrolytic dielectric capacitors. Here of course you have to know two things. Number one is its polarity, and number two it is voltage and capacitance rating. Usually in this type of capacitors, the voltage and the capacitance are printed on it, but the polarity, which is very important because you are going to connect it in DC, you have to know which one is positive and which one is negative. So usually you will find it like this. The two terminals are coming out like this. One is a longer terminal, the other one is a shorter one. So now usually you will have the longer one as positive, the smaller one as negative. And there is another check to it. If I find a continuity between this shorter one and the body, it will show a continuity that shows that the body is also negative, the smaller one is negative, and the longer one is positive. So this way you can check its polarity. Now in case of a capacitor, it can be either short or open, or it can be healthy also. So I write short, open, healthy. Let us see. Short means if I connect it across a multimeter, it will show you 0 resistance. If it is open, what do you think? It will show infinite resistance. And if it is healthy, it will show you some resistance which is not 0 and which is also not infinite. But we cannot say that if a capacitor is not short, not open, it has to be healthy. There is another check to a capacitor which is known as leaky. A capacitor can be leaky, and this is known as leakage test. What does it mean? You know, I have told you that when I give a supply across a capacitor, it will get charged, and then afterwards it will discharge. Now if a capacitor shows charge and discharge, that means it is a healthy capacitor. But if it does not show the discharge, it shows the charge but it does not show the discharge, in that case we will say that it is not a healthy capacitor. It is not short, it is not open, but at the same time it is not healthy. It is a leaky capacitor, and such capacitors should not be used in any circuit. Now all these things can also be tested with the help of a multimeter. Now the values can be easily checked with a digital multimeter, but for checking the charge and discharge we prefer analog multimeter, and I will request Mr. Singh to demonstrate the values as well as the charge and discharge of a capacitor with the help of digital and analog multimeters. So you see, we are going to check the value of this ceramic disc type of capacitor with the help of a RLC digital meter. Here it is showing 0.21, and if you remember, I calculated the value of this capacitor to be 0.22 microfarad. So we can take it as 0.22 microfarad. The next one, we saw the value of a polyester type of capacitor, and it was 0.047 microfarad calculated. Here this meter is showing 0.048, so it is 0.047 microfarad. Again this value was calculated as 0.1 microfarad, and the meter is also showing 0.101 microfarad. Now we are going to check the charging and discharging of a dielectric type of capacitor with the help of an analog multimeter. You see, here it is charged and now it is gradually discharging. It is, the capacitor is discharging. So what does it show? It shows that this particular capacitor is a healthy capacitor. So we have discussed the two important components, that is resistors and capacitors, and also what is power electronics in this film. In the next part of the film we are going to discuss the three next important components: the diodes, the transistors, and the uni-junction transistors, UJTs. Thank you.